So guys, as you can see that over here, this blue LED is blinking. This means that something is being sent to the computer. PIC is sending something to the computer. As you can see that LED is constantly blinking. So let's go to the USART terminal and see what data is being sent. Now guys, if I go there, let me zoom in so you can see better. Now see that COM4 baud rate is 9600. That's what I did in the programming. See, okay, it is sending ABCD to the computer. See, A, B, C, D, E, F, G, H and star. Okay, now let's see what we did in the programming. That's why it's sending this. See that first of all we initialize the software serial port like this at pin number D0 and D1. D0 is the RX, D1 is the TX, and baud rate is 9600. Then we are sending C, A, B, C, D, E, F, G, and finally a star and a 2-second delay. So this all gives us the result over here in the serial terminal. So guys, that's it. Guys, welcome to learning microcontrollers. In this video, I will show you how we can use software serial library to send characters from PIC16F877A to PC using USB to TTL device. So software serial library is a very useful library, especially in Arduino. We make a lot of use of it, but this is also available in MikroC as well to send characters. Guys, you can turn any pin of your microcontroller into a UART port using this library. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this over here is a USB to TTL device CH340. You can use any type of USB to TTL device, all do the same. I'm going to use a CH340 or FT232 or any you can use. I'm going to use the CH340. So guys, let me first label up the device. It's labeled already, but I'm going to again label it up. From the left is the 5-volt pin, then we have VCC, then we have 3.3-volt pin, TX, RX and ground. Now whichever USB to TTL device you take, TX, RX and ground pins are always there. These 3 pins are all part of every USB to TTL device. While rest of these 3 pins, 5-volt, VCC, 3.3-volt, they may differ, like some do have 3.3-volt, some don't have some 3.3-volt, etc. So TX, RX and ground are always there. Now guys, to connect this with the PIC, we will need the UART port of the PIC, but we are going to use the software serial library, so we can turn any pin into a UART port. So what I do is that, first of all, I connect the ground of the USB to TTL device with the ground of the PIC like this. Now for the RX pin of the USB to TTL device, I can use any pin as TX. So I use the pin number D1 as a TX. Remember that UART port of the PIC is pin number C6 and C7, while we are connecting it to the D1. Now that's the beauty of the software serial communication, that you can turn any other pin as serial pin, like it can be turned, any pin can be turned a UART pin. Now it's an RX pin, and now for the TX pin, it will go to the RX pin of the PIC. So I connect it to the pin number D0 like this. In this way, TX goes to RX and RX goes to TX. That's how you are going to program it. Now these 2 pins D1, D0, we will define in the programming that we are taking D1 as the TX pin and RX as the you can say the RX pin of the PIC. So this will be our software serial UART port D0 and D1. Now before we continue, let me introduce you to the hardware. Guys, this over here is our hardware. As you can see, this is the USB to TTL device. As you can see, only 3 wires are connected. I didn't connected any power wire because computer is going to power up the device on auto. See, it is connected to the USB port of the computer. Computer will auto power up the device, while rest of our circuit, that is over there, is the PIC16F877A. This all bunch up is just a trainer board. That PIC16F877A will be powered up using a PIC3 programmer tool. See, that is connected over there. So I will power up the PIC using PIC3 programmer tool, and the USB to TTL device will be powered up from the computer. That's why we do not need to connect these 3 wires at all. Now guys, let's get to the MikroC for PIC to getting started with the programming. So this is our MikroC for PIC. Let me zoom in so you guys can see better. Now this over here is the latest version 7.6.0. It's a free version. I had shown in my previous video, whose link will be in the description, how to download and install this free version from the official website. It's free up to 2K of programming memory, and this program is not going to take even 300 bytes of memory. So let's get started. Click on File, New project. This window pops up, New project wizard. Click on Next, write the name of the project. I write here Soft Serial Tutorial by Learning Microcontrollers. That's all. And this is the path where the files will be created. Click on Browse, select the path where you want to create the files. I select a path like here, new codes on the desktop, click OK, and now select the microcontroller you are going to use. I am going to use a PIC16F877A. Now this is the crystal speed, and the crystal I have at the pin number 13 and 14 of the PIC16F877A is a 20 megahertz crystal. So I will write 20 over here. Now click on next and finish. Now guys, this window pops up. Before you do anything else, first of all, you have to save your work. So press Ctrl S. This window pops up, click on save. Okay, the work is saved. Now guys, go to the right, expand the MikroC libraries, then the system libraries. Here you have here software UART library, expand it, check mark this, and in that library look for this command software UART I90. Double click on it. This window pops up. Here you can see that prototype, it is showing that first of all you enter the port, then you enter the RX pin whichever you want to use, then the TX pin that you have selected. In our case they are D0 and D1, and then you select the baud rate, and then after that there is an inversion technique that if you write any value other than 0, it will simply invert the output. Like instead of sending 0101, it will send 1010, or that's all. Now guys, here in the example of this command, you have this command over here, software UART I90, copy it from here till here. That's all. Now go back, paste it on the below the void main like this. Now give some initialization delay. This delay is not necessary, but I always suggest give it in the one time loop. Now in this software UART I90 command, you can see that this is the port, we are using port D, and for the RX pin we are using pin number 0, and for the TX pin it's 1, and the baud rate I am going to use is 9600. You can set any baud rate, and 0 means it's non-inverted output. So simple as that. So this is our software serial command, initialization command. Now go to the forever loop. I write while 1 forever loop starts here, ends here. Now we send some ABCD to the serial terminal, to the computer. So to send the ABCD, go to the right again, and here you have this software UART write command. Now double click on it. This window pops up, and here in the example you have this command software UART write some byte. There you can send a byte. Now this is the difference in the software UART and the hardware UART, that you can only send a byte, not a string. So if you want to send a string, then you have to send it in the form of bytes. You cannot directly send a string using this library. So we send a character, like we send alphabet A like this, and A will be sent. Then we give some delay like this. 100 is less, I give like 200 delay. Okay, make it 500, that after half a second it will send the next value. So it sent A now, then we will send a B, then we send a B, now it's B, then we send C and D, C, D, then we send some random characters like ABCD, C, D, then E, F, G, H like this, and then finally after H it will end, and we will send some other character to show that it had ended. We send a star. Okay, then it will send a star. It means that it has ended. Now it will start all over again, and once it sends a star, it will wait for 2 seconds, and then it will start A, B, C, D, F, G, H. After half a second it will send B's, then C, D, E, F, G, H, and finally when the star comes, then it will wait for 2 seconds, and then will start all over again. So let's build this code and see what happens. See, it's built successfully, and the programming words it used are 1000 words, and this version 7.6.0 free version is free up to 2K of words. So we still have 50% free memory. So no issue with that. So it's built. Now let's go to the PIC16 programmer tool to burn it into the microcontroller. So this is our PIC16 programmer tool. Go down and look for the PIC16F877A microcontroller in the list. That is what I'm going to use here. PIC16F877, this one. Now go to the file, import the hex file we just created. So this is a hex file. Double click and click on write. Okay, the new file is being written. Let's get to the hardware and see what happens. So this is the hardware. Okay, the file is written. I will power up the circuit using the PIC16 programmer tools. Power, click on. Okay, the power is on. You can see that it is blinking blue. It means the data is being sent. See, now we go to our USB to TTL terminal and see what is being sent. See, now it is blinking over here. You can see that the TX LED is blinking, that something is being sent to the computer and computer receiving that data. So let's go to the PIC16. Okay, go to your MikroC. Let me zoom in. Go to the tools. Here you have this USART terminal. Click on it. This window pops up. Okay, select the port. My port is COM4. Whenever you install the USB to TTL device driver, it will assign a COM port. You have to remember that whenever you plug in that device. 9600 is the baud rate we use in the programming. So 9600, and these are the defaults. Now click on connect. Okay, here see that we are receiving the data. See, A, B, C, D, E, F, G, H, and then star and 2-second delay. A, B, C, D. See, it is working like a charm. See guys, see. So that's how you can use the software serial library of the PIC16F877A microcontroller using MikroC for PIC. If you guys have any questions, you can ask me in the comment. And thank you very much for your time, guys, and we'll see you in the next video. Goodbye until then.